morning children. In today's class we are going to learn the definition about differential. Before that, let us remember, you have a curve, the point where I draw the tangent. This point, say x value x, here I call the curve to be y equals f of x. So if this is x, this height will be f of x, the height. And I have taken another point with a small increment in x. Del x we call a small increment in x. So I have taken this point as x plus del x. So what will be this height? It is f of x plus del x. Now, how to find the slope between the 2 points? The slope between the 2 points, we say y2 minus y1 by x2 minus x1, or I will call f of x plus del x minus f of x, y2 minus y1 divided by x2 minus x1, x plus del x minus x. This x and x gets cancelled. Now I have f of x plus del x minus f of x by del x. When limit del x tends to 0, that is this point almost coincides here. Del x tends to 0. This idea we call dy by dx, or I can say f dash of x. From this I can cross multiply and say what? Limit del x tends to 0, this idea I call dy by dx, or I can call it as f dash of x. So this is differentiation from the first principles what we had learnt already. This small length del x is nothing but dx. When I approximate, del x I can rewrite as dx, a change in x value, a small change in x value. If so, how do I define the differential? If f is a function from an open interval ab to real numbers, if f is a differentiable function for x in the open interval and del x the small increment given to x, we define the differential of f by df equals to f dash of x del x. Suppose f of x is x. What is f dash of x? X becomes 1. Instead of f, it is x now. So instead of f, I can write dx, which is f dash of x del x. F dash of x is 1. So 1 into del x. This idea gives me dx and del x are equal, which we have changed here. So del x we say a small change in x-axis. Is it the same when I come to del y and dy? We must know. The line, when I check, the tangent line is there, the curve is there. This small distance, the change in y value with respect to the tangent line, I call dy, whereas the full change with a curve I call del y. Remember, the height changes, that is f of x, y value changes. With the curve I find the change, it is del y. But if I find out the increment in f along the tangent line, I call it as dy. If the point is closer and closer, they are also equal. only when the point is almost closer. Del y and dy are also equal. Now combining these two, instead of del x, I can put dx. Comparing this increment along the tangent line, which I call as dy or df, because y is equal to f of x. Instead of dy, I can very well say df. Combining these two, I have deduced the formula dy equals f dash of x dx, and we will apply this in the exercise problems. So the differential we call dy, which is f dash of x dx. Let us see some examples. Suppose y equal to sin x. What is dy by dx? I call this as derivative. Dy by dx, I will say cos x. But if I ask you what is dy, it is derivative into dx. So sin x will become cos x into dx. Remember, this I call dy by dx, or derivative of y with respect to x. Change in y with respect to x. That is cos x. But if I say dy alone, I call it as differential. And dy equals cos x into dx. So that is the only change. Almost all the problems you will be able to do it. The only idea, here I write dy by dx, whereas here I write dy equals f dash of x into dx. Let us remember this and continue doing exercise problems. Exercise 8.2, question number 1. Find the differential dy for each of the following. Y equals 1 minus 2x the whole cube by 3 minus 4x. As we read the problem, let us take u as the numerator and v as the denominator to ease our calculation. We are going to apply this for this problem. Y, we will write dy equals f dash of x into dx. Instead of f dash of x, we will apply this formula. V u dash 3 minus 4x into u dash minus 6 1 minus 2x the whole square minus u v dash 1 minus 2x the whole cube into v dash is minus 4 divided by v square 3 minus 4x the whole square into dx. Do not forget. We will simplify. Dy equals, in both the terms, 1 minus 2x the whole square is common. Also, here minus 6, here minus 4. So I can take minus 2 out. What remains? 1 minus 2x the whole square and minus 2 is taken. We are left with 3. 3 into 3 minus 4x. Minus 4, I have taken minus 2, so 2 left out. Minus 2 into 1 minus 2x the whole cube. We have taken 1 minus 2x the whole square. So 1 minus 2x power 1 is remaining. Divided by the denominator 3 minus 4x the whole square. Never forget to put dx. Dy equals minus 2, 1 minus 2x the whole square. Simplify this. 9 minus 12x. Minus 2 into 1. Minus 2 into minus 2x. Into dx. Divided by 3 minus 4x the whole square. Or one more step we can write. Minus 2 into 1 minus 2x the whole square into minus 12x plus 4x is minus 8x. 9 minus 2 is 7 into dx divided by 3 minus 4x the whole square. I will get dy equals 2 into 1 minus 2x the whole square into minus 8x, 8x minus into 7 minus 7 dx divided by 3 minus 4x the whole square, and that's the final answer. Second subdivision, find differential dy for y equals 3 plus sine 2x the whole power 2 by 3. Something power. So remember the formula x power n. I will write nx power n minus 1. So y we write dy equals f dash of x into dx. dy equals differential 2 by 3 plus sine 2x the whole power 2 by 3 minus 1 into power rule over. Apply what is inside. Constant will become 0 plus sine 2x will become cos 2x. 2x will become 2 into dx. First the power rule, 2 by 3, whatever is inside the bracket, power 2 by 3 minus 1. Hide the power. 3 constant will become 0. Sine will become cos. So sine 2x will become cos 2x into hide sine. 2x will become 2. The full differential over, remember to put dx. Now we will simplify and write 2 into 2, 4 cos 2x divided by 3 into 3 plus sine 2x the whole power 2 by 3 minus 1, 2 minus 3 minus 1 by 3 into dx. Leave the answer like this or bring the negative power to the denominator. 3 plus sine 2x power 1 by 3. The numerator we have 4 cos 2x into dx, and that is the answer. Third subdivision, y equals e power x square minus 5x plus 7 into cos x square minus 1. There are two terms. How should you do it? The formula dy equals f dash of x into dx. dy equals, keep the first term, e power x square minus 5x plus 7 into cos will become minus sine x square minus 1 into hide cos x square will become 2x, 1 will become 0 plus keep the second term cos x square minus 1 into differentiate the first term e power x square minus 5x plus 7. Remember e power x, the derivative is also e power x into. Differentiate the power. X square will become 2x, 5x will become 5, 7 will become 0. The entire thing into dx. See what term is common? Let us take it out. E power x square minus 5x plus 7 into minus 2x sine x square minus 1 plus 2x minus 5 into cos x square minus 1 into dx, and that is the final answer. So these are the problems where we adopt the derivative rules, wherein we have two terms. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. Cos will become minus sine, e power will become e power, and ordinary formula x square becomes 2x, x becomes 1, constant becomes 0. So remember the idea so that any problem is at your step. Second question, find df for f of x equals x square plus 3x and evaluate it at the given values. F of x is given. So what is the formula for df? it is f dash of x into dx. Or we will say x square becomes 2x, 3x becomes 3 into dx. Given x is equal to 2 and dx equals 0.1. So df equals 2 into 2 plus 3 into 0.1. 7 into 0.1, or the answer is 0.7. Similarly, the second part, f of x is given as x square plus 3x. df equals f dash of x into dx. df equals x square becomes 2x, 3x becomes 3 into dx. Or now x is 3, dx is 0.02. 2 into 3 plus 3 into 0.02. 6 plus 3, 9 into 0.02, or it is 0.18, and that is the answer. Question number 3. Find del f and df for the function f for the indicated values of x, del x, and compare. F of x equals x cube minus 2x square given x is 2. Del x or dx is 0.5. What is df? The formula f dash of x into dx. df equals, differentiate 3x square minus 2 into 2x. X square becomes 2x, x cube becomes 3x square, the whole thing into dx. Or I will say it is 3x square minus 4x into dx. Now x is 2 and dx is 0.5. So df equals 3 into 2 square minus 4 into 2, the whole thing into 0.5. 4 3s are 12 minus 8 into 0.5. 4 into 0.5, that is 2.0. So df we have got 2.0. What is del f? F of x plus del x minus f of x. In this question, x is 2 and del x is 0.5 minus f of x is 2. Or I get f of 2.5 minus f of 2. What is f of x given? X cube minus 2x square. F of 2.5 is 2.5 the whole cube minus 2 into 2.5 the whole square. 2.5 the whole square is common. Taking out, we are left with 2.5 minus 2. Or f of 2.5 is 2.5 the whole square, 6.25. 2.5 minus 2, 0.5. Multiplying, we get 3.125. Finding f of 2. It is 2 cube minus 2 into 2 square. 8 minus 8, that is 0. My question is to find del f. Del f is 3.125 minus 0, or I get del f is 3.125. Therefore, actual change del f is 3.125 and estimated change df is 2.0. Second subdivision, f of x equals x square plus 2x plus 3. What is df? F dash of x into dx. df equals x square becomes 2x, 2x becomes 2, constant becomes 0 into dx. Given x value minus 0.5 and dx is 0.1. df equals 2 into minus 0.5 plus 2. dx is 0.1. 2 into minus 0.5 minus 1 plus 2. into 0.1, or it is 1 into 0.1, that is 0.1. Finding del f of x plus del x minus f of x. F of x value minus 0.5 plus del x is 0.1 minus f of minus 0.5, that is f of minus 0.5 plus 0.1 is minus 0.4 minus f of minus 0.5. What is f of minus 0.4? Substituting here, minus 0.4 the whole square plus 2 into minus 0.4 plus 3. As we simplify, we get 2.36. In the similar way, wherever minus 0.4 comes, I can put minus 0.5 and we get 2.25. Substituting in del f, 2.36 minus 2.25 gives us 0.11. Actual change we call del f, which is 0.11, and estimated change is df, which is 0.1. Let us remember, subtracting df from del f, we get error. So what is error? It is actual minus approximate. That is del f minus df is nothing but error. Let us remember that to find one word answers. Question number 4. Assuming log e base 10 is 0.4343, find an approximate value of log 1003 base 10. If you are given a question like this, approximate value, let us remember the formula. Del f equals f of x plus del x minus f of x. Suppose my question is f of x plus del x. Bring f of x here. So, f of x plus del x equals to f of x plus del f. We are going to apply this in this problem. 1003 I take as x plus del x. So what is x? Find out when it is base 10. Log of which closer number I know? Log 1000. Log 1000 base 10 I know very well, it is 3. So take x as 1000. If x plus del x, the given question 1003, and the nearing value that I know is 1000. What is del x? The difference. It is nothing but 3. As I know it all, I must find out what is fx and del f. What is f of x? In this question, we want log of some number. That some number place I will take x. So log x base 10 I will define as f of x. When x is 1000, what is f of x? It is log 1000 base 10 and that is 3. So I know this answer for sure. F of x I found out. What is my next step? I must find out what is del f. For finding del f, let me remember this easy formula df. What is df? F dash of x into dx. So df equals f dash of x. Differentiate. Log x will become 1 by x provided the base is e. Let us remember log x base e, the answer is 1 by x. But any other base is coming. I will write 1 by x log e base a. In this question, base a is 10. So, f dash of x, log x will become 1 by x log e base 10 into dx. In this question, they have given what is log e base 10. 0.4343. What is dx? It is nothing but del x only. So 3 divided by, what is x given in the question? 1000. Let me simplify. What is df? We get 0.0013029. Let us substitute in the formula. F of x plus del x equals f of x. The answer is 3. Del f, what we have calculated here, approximately equal to this, plus 0.001329. So f of x plus del x, we will say 3.001329. It is an approximate measure. We say 3.0013. So this is log 1003 base 10.